My videos can only go up to 15 minutes. Way I do it, I post it to YouTube, then I download it to Folio. Can't go beyond 15 minutes, so I do keep track of the time. So we are right up here. This is still the original, but it's in a much more calculus-friendly format. And so recapping, since I had to kind of stop at a bad place there, recapping, I had an other base logarithm. So the first thing I do is I'm going to use this formula and change it to natural logs because I know what to do with natural logs. So this became natural log of e to the x over natural log of 25, natural log of 3x over natural log of 5. Then we know that natural log of e to the x is x, and this natural log of 25 is just a number. It's just a coefficient. Bring it out to the front and leave it. And then the same thing here. This natural log of 5 is just a number. Just bring it out to the front. Where both of these guys are just coefficients. And so now when I differentiate, write down the coefficient. 1 over natural log of 25. The derivative of x, very specifically, is 1. Write down the other coefficient, 1 over natural log of 5. Then 1 over the argument, derivative of the argument. 1 over argument, derivative, argument. The 3's cancel. And so a wonderfully pretty answer, 1 over the natural log of 25 minus 1 over x, natural log of 5. And there's a good enough answer. Okay, last problem in this section. This was a long section. Differentiate the following. Again, we've got to simplify. If a problem looks like a god-awful mess at the very beginning, that is really a good indication that you probably need to try to simplify. So simplify first, and we're going to use that log base b of x is natural log of x over natural log of b. So this is going to become, and let's take one other step before I get to that. Well, it's going to take several simplification steps. We'll go ahead and do that first. There is no one correct way to go through the simplification first, but I will go with my change of base formula. And so this becomes natural log of the square root of 7x over 3x plus 1 raised to the natural log of 5 all over the natural log of 5. Keep simplifying. This is just a number. Just a number. So I'm just going to call it 1 over natural log of 5 and have it out there as a coefficient. Students have a tendency, they freak out when they see natural logs or logs of any sort. But that's just a number. So I'm just going to bring out the side and I'm going to worry about this other stuff. Still simplifying. And that's going to be 7x over 3x plus 1. Let's try to make it a little more legible, shall we? It's going to be 7x over 3x plus 1 to the natural log of 5. And then that whole thing to the 1/2. That a square root is the same thing as an exponent of 1/2. Keep simplifying. Exponents to exponents. We multiply. This is 1 over the natural log of 5 times the natural log of 7x over 3x plus 1 to the 1/2 natural log of 5. Keep simplifying. Use power rule for logs. So I'm going to have 1 over the natural log of 5 times 1/2 natural log of 5 times the natural log of 7x over 3x plus 1. Those guys cancel. Use quotient rule for logs. So I'm going to get 1/2 times the quantity, natural log of 7x minus natural log of 3x plus 1. And there is my fully simplified original function. But it's not scary anymore. And so again, I've said so many times, always simplify if you can. Simplify first if you can. By doing the simplification, I've come away with something that just really isn't too hard. And so now the derivative, that 1/2 is just a coefficient, just write it down. You do not need a product rule for coefficients. Then 1 over the argument, derivative of the argument, 1 over the argument, derivative of the argument, 1 over argument, derivative argument, 1 over argument, derivative argument. Here the 7's cancel. And so I get 1/2 times 1 over x minus 3 over 3x plus 1. And that is a good enough answer. I would not expect you to take it any further. But the real key to this one was the simplification. And we can get it all on one page. First, I applied the change of base formula, then what the radical meant, exponents to exponents multiply, and then it was my properties of logarithms that allowed me to simplify it to something that wasn't scary at all, and so then I could do the derivative. And that concludes this section.